If it were up to me to choose any item, and when I say any item, I really mean anything to keep me company here at home at this precise moment, my choice would not fall on a teleportation device. But I confess that this decision would not be made without hesitation. Consider the infinite possibilities that teleportation unlocks. I would have the freedom to explore any corner of the globe without worrying about travel costs or the risk of prolonging my stay to the point of boredom, as I could simply activate the device and return to the comfort of my home. What's more, I could venture into space, visit other planets, and, depending on the capabilities of the teleportation device, perhaps even explore different star systems. Imagine being the first person in history to meet and interact with extraterrestrial beings. However, there is one major caveat. A teleportation machine is likely to end up being fatal on its first use. Imagine you have a jigsaw puzzle. No, not one of those that you put together on a rainy afternoon, but a puzzle that challenges the mind, one that makes you question the reality around you. Today we're going to talk about a puzzle that has been around for centuries, but is still as fresh as a new episode of your favorite series. I'm talking about the famous paradox of the boat of Theseus. Have you ever heard of it? Well, imagine an ancient wooden boat, anchored in a port where storms are more frequent than sunny days. With each storm, a part of the boat is damaged and needs to be replaced. Year after year, storm after storm, every part of the boat is replaced, until one day, none of the original parts remain. Here comes the big question. Is this boat, completely renovated, still the same boat as before? But wait, the plot could get even more complicated. Imagine that the zealous port official has saved every single part that has been replaced and, as a weekend project, has decided to rebuild the original boat, piece by piece. In the end, we have two boats. One that never left the port, but was completely renovated, and another assembled from scratch with the original parts. Which one is the real boat of Theseus? Now think with me. This paradox is not limited to boats and pieces of wood. It extends to us human beings and even to futuristic technology, such as teleportation. If we could teleport, disassembling our molecules here and reassembling them elsewhere, would we still be the same person? And here's a thought for fun. If we change all the parts on an old car, does it pass inspection as new or vintage? This paradox invites us to reflect on identity, change, and continuity. It shows us that perhaps the essence of something, or someone, is not just in its physical parts, but in its history, memories, and lived experiences. Let's say science has advanced to the point where teleportation has become a reality. You enter the machine here, and a copy of yourself is created elsewhere. But that copy, is it still you? It has your memories, your feelings, your dreams. But what about your essence? Some say that what we really are is beyond atoms and molecules. It's in the continuity of our consciousness, which many believe is in the brain. But what if we could transplant the brain into another body, or copy the exact memories of one person into another? This brings us to a profound discussion about identity and existence. Now, let's apply this to teleportation. When you teleport, the original you disappears, and a new you appears with all your memories. But this break in continuity raises the question, is this new you really you? It seems that if we follow the logic of physical continuity, the new you may have the appearance of the original you, but deep down, it's not the same. But then, is this new you, with all your memories intact, still you? Just think, this new you would remember everything. Your childhood fights, your first loves, the movies that made you cry, the songs you can't get out of your head, even your peculiar taste in white socks. He would have lived it all, in theory. If we consider that our memories are the core of our identity, then this new you, who appeared out of nowhere after the teleportation, never really stopped being you. Even if someone came along and told you, "Hey, you're a copy," would it really matter? For this new you, life goes on as usual, with a past, a present, and dreams for the future. Everything around us, including ourselves, is made up of tiny particles called atoms. These atoms are always moving, and because of this movement, they don't stick together perfectly. This means that there are tiny gaps between them. It's as if the world were a Swiss cheese on a microscopic scale, full of holes invisible to our eyes. Let's suppose that the universe is like a sheet of paper. Now think that instead of traveling the entire length of that sheet to get from one point to another, you could simply fold it, bringing two distant points closer together. Wormholes are like these folds in paper. They connect two distant points in space, so that, theoretically, you could cross that distance almost instantaneously. It's as if these holes were hidden shortcuts in the universe. Now the tricky part, around these shortcuts, there are areas with such strong gravity that they could stretch and crush anything that came close, almost as if you were a spaghetti being stretched. What's more, these holes don't stay open for long. They open and close quickly. So even if it were possible to use them to teleport, it would be extremely dangerous and practically impossible to do in reality. So, although the idea of traveling instantly through space using wormholes is fascinating, it is something that, for the time being, remains more in the realm of theory and science fiction than in practice. Quantum teleportation sounds like something out of a science fiction movie, but it's actually a real concept that scientists are already starting to use. Only, instead of teleporting people or entire objects like in the movies, quantum teleportation works by transferring information. To understand this, think of quantum mechanics, which is the part of science that studies how things work on a very, very small scale, like atoms and particles. On this tiny scale, the rules are a little different from what we're used to in our big world. An example of this is quantum superposition. Imagine an electron, a very small particle, which can be in several places at once. It's a difficult concept to grasp because we don't see it happening in our everyday lives. But in the quantum world, this is normal. Now, the moment you decide to check where that electron is, it chooses a place to be. Quantum teleportation uses these crazy ideas to send information from one place to another instantly. Instead of sending physical matter like our bodies, it sends what we could call a quantum description of something from point A to point B. This may sound less exciting than jumping instantly to Paris, but it's a big deal for things like ultra-secure communication and the super-powered computers of the future. In the microscopic world of quantum mechanics, electrons, which are very tiny particles, can form a special kind of partnership called quantum entanglement. It's as if they become inseparable best friends, no matter how far away they are from each other. Even if one goes to one side of the universe and the other to the opposite side, they can still talk instantly. Each electron rotates or has a spin, which can be thought of as turning left or right. When two electrons are entangled, if you change the spin direction of one, the spin of the other will instantly change to the opposite direction, as if they were communicating faster than light. This is super string because, according to the laws of physics, nothing should be able to travel faster than light. So even though we're talking about something that happens on a very, very small scale, quantum entanglement shows us that the universe has mysteries that are truly fascinating and a little crazy. In the 1980s, a scientist called Alain Aspect carried out some tests and discovered something incredible. It seems that some tiny particles, when they form a special pair, can talk to each other faster than light. But at first, this conversation didn't seem to be of much practical use because it was all random. But then, about 10 years later, scientists found a way to get in on the conversation by adding a third particle to the chat. This opened the door to something that sounds like magic, teleporting individual particles from one place to another. In 2006, a group in Vienna even used this idea to teleport a type of gas over a distance of 2,000 feet, almost 600 meters. And in 2017, scientists in China went one step further, teleporting a particle called a photon more than 310 miles, approximately 500 kilometers, into space using something called quantum repeaters to ensure that the particle didn't get lost along the way. And this whole teleportation thing isn't just a cool trick. It has enormous potential for creating super powerful quantum computers that are practically impossible to hack. Why? Well, if anyone tries to eavesdrop on the information being transferred, the particles involved change instantly, and you'd know right away that someone had tried to tamper where they shouldn't have. Companies like IBM and Google are racing to build these supercomputers. In the future, scientists hope to use this technology to perhaps teleport even bigger things, perhaps even human beings. To do this, they would have to scan and reassemble an absurd number of particles that make up a person. Just imagine, one day we could upload ourselves to a distant place in the blink of an eye. And you, if you could use teleportation today, where would you like to go?